Ever pondered on what keeps the universe together, what makes the planets orbit, or why you're not floating in your room right now? Well, it's not by some random chance or the will of the cosmic gods. It's the work of the fundamental forces of nature. These are the silent heroes, the unseen puppeteers that shape our reality and give structure to the cosmos. Now, you might be wondering, what are these fundamental forces? Picture the universe as a grand orchestra. Each instrument plays its part, contributing to the harmony of the celestial symphony. Similarly, our universe is orchestrated by four fundamental forces: gravity, electromagnetism, strong nuclear force, and weak nuclear force. Each one has its unique role and range of influence, and together they compose the intricate ballet of the cosmos. Imagine gravity as the maestro, dictating the ebb and flow of galaxies, stars, and planets. It's the force that keeps your feet firmly planted on the ground and governs the majestic dance of celestial bodies. Then there's electromagnetism, responsible for the light we see, the sounds we hear, and even the thoughts we think. Next up, we have the strong nuclear force, the glue that holds the protons and neutrons together in the nucleus of an atom. And finally, the weak nuclear force, responsible for radioactive decay and the fusion reactions that power the sun. Today, we will delve into the realm of these invisible forces that shape our reality. Imagine a world without gravity. Sounds fun, doesn't it? But what would that really mean? Let's take a moment to appreciate this invisible force that keeps our feet firmly planted on the ground and our planet rotating in a perfect orbit around the sun. Gravity, as we know it, was first comprehensively discussed by the great Sir Isaac Newton in the 17th century. He introduced the concept of a universal force that attracts two objects towards each other. It's the reason why an apple falls from a tree to the ground and not the other way around. But Newton's theory was just the beginning. Gravity is also responsible for the celestial dance that happens in our universe. It's the force that holds the planets in their orbits around the sun. It's the reason why the moon circles the earth and why we experience tides. Now, you might be wondering, if gravity is so important, why is it considered the weakest of all fundamental forces? Well, it's true. Gravity is about 39 orders of magnitude weaker than the strong force, the force that holds the nuclei of atoms together. But despite its weakness, gravity has a reach that other forces can only dream of. It's the force that binds galaxies together and shapes the large-scale structure of the universe. In the 20th century, Albert Einstein brought a new perspective on gravity with his theory of general relativity. He proposed that gravity is not just a force, but a curvature in the fabric of space and time caused by mass and energy. This groundbreaking concept led to the prediction of gravitational waves, ripples in space-time caused by accelerating masses, which were finally detected in the 21st century. So let's put it all together. Gravity, although the weakest of all forces, has an infinite range and is responsible for the large-scale structure of our universe. It's the force that keeps us grounded, quite literally, and without it, the world as we know it would cease to exist. Gravity, the weakest yet the most influential force, truly keeps us grounded. Ever thought about why magnets attract or how your phone works? It's all about electromagnetism. This force, second in our list of fundamental forces, is responsible for a vast range of phenomena that make our daily lives possible. To understand electromagnetism, we must travel back in time to the 19th century, when a brilliant scientist named James Clerk Maxwell unified the previously separate forces of electricity and magnetism. He showed the world that these two forces were two sides of the same coin, and this coin was called electromagnetism. Maxwell's equations, as we now refer to them, provide the backbone for our understanding of how charged particles interact. When a charged particle moves, it creates a magnetic field around it. Similarly, when a magnetic field changes around a charged particle, it creates an electric field. This constant dance between electricity and magnetism is what we call an electromagnetic wave. And guess what? Light, that thing which makes our world visible, is just an electromagnetic wave. But the influence of electromagnetism doesn't stop at the microscopic level. It stretches out to the macroscopic level, influencing the behavior of galaxies and everything in between. Electromagnetic forces hold electrons in their orbits around nuclei, creating the atoms that make up everything we see, touch, and feel. And what about the devices we can't live without? Our phones, computers, and televisions, all of them work on the principles of electromagnetism. The signals that allow us to communicate across continents in the blink of an eye, electromagnetic waves, the magnetic strip on your credit card, you guessed it, electromagnetism. Electromagnetism, the force behind light, electricity, and magnetism, illuminates our world in more ways than one. So, the next time you switch on a light, send a text or use a magnet. Remember, you're harnessing one of the fundamental forces of our universe. What keeps the nucleus of an atom together? And what causes radioactive decay? Welcome to the world of nuclear forces. Let's dive into the heart of an atom and explore the strong and weak nuclear forces, the unseen power within. We begin our journey with the strong nuclear force, a force so potent that it binds the protons and neutrons within an atomic nucleus. Despite the repelling electromagnetic force between protons, the strong nuclear force overcomes this repulsion, holding the nucleus intact. Fascinating, isn't it? But here's the catch: it operates only at very short distances, about the size of an atomic nucleus. Now let's shift our focus to the weak nuclear force, the shy sibling of the strong nuclear force. This force is responsible for radioactive decay and nuclear fission. It's the weak nuclear force that allows a neutron to change into a proton, an electron, and a tiny particle called a neutrino. This transformation is at the heart of radioactivity. Similar to its stronger sibling, the weak nuclear force also has a limited range, even shorter than the strong force. However, don't let the names fool you. The terms strong and weak do not imply any inferiority or superiority. They merely refer to the relative strengths of these forces. The strong force is about 100 times stronger than the electromagnetic force, and a whopping 1,000,000 times stronger than the weak force. But remember, without the weak force, we wouldn't have the sun's heat, or life on Earth for that matter. The strong and weak nuclear forces, though confined, play a crucial role in the very existence of matter. They are the unseen heroes, operating behind the scenes, holding our universe together. So, the next time you look at anything, remember the immense power it holds within, courtesy of these nuclear forces. So, we've journeyed through the universe, exploring the fundamental forces that govern it. We've tackled gravity, the ever-present force that binds, keeping our feet firmly on the ground, and the planets in their celestial dance. We've illuminated electromagnetism, the force that lights up our world, powers our devices, and even keeps us warm on cold winter nights. Then we ventured into the atomic heart of matter, where we found the strong and weak nuclear forces at play. The strong nuclear force, the glue that holds the nucleus together, and the weak force, the subtle shaper of radioactive decay. These forces may seem distinct, but they're interconnected, each playing a vital role in the cosmic theater. They shape galaxies, ignite stars, and even influence the very atoms that make up you and me. They're the unsung heroes of the universe, tirelessly working behind the scenes to create the reality we experience every day. These forces, though invisible, are the threads that weave the fabric of our universe. Our journey today has only scratched the surface of these fascinating forces. The universe is a vast, intricate tapestry woven with threads of gravity, electromagnetism, and the nuclear forces. Each thread is a story, a mystery waiting for curious minds like yours to unravel. We're talking about forces that have birthed stars, shaped galaxies, and even made life possible. But there's so much more to learn, to explore. Each question answered only gives birth to a dozen more. And that's the beauty of it all, isn't it? This endless dance between knowing and not knowing. So let's keep this dance going. Let's spread the word, the knowledge, the curiosity, and the fascination. Don't forget to like, comment, share this video, and hit that subscribe button. Until next time, keep exploring the wonders of our universe.